Hello everyone, welcome back. This is a presentation about block diagrams. Block diagrams are really important in describing the top level design entity of our projects. Um, as a definition, I have here a couple of statements inspired from how this is talked about on Wikipedia. I like the definition or the description of a block diagram as being a bunch of components of our design that are interconnected with lines showing the connections and the relationships between those blocks. That's what we're looking for. They're really useful for several different purposes. They help us simplify, better communicate our design, describe it to other people, include such block diagrams in our reports, and then during the description of those components we cross-reference, cross back to the block diagram and just create a better presentation and conveying of our ideas and what our designs do. It's very helpful, useful to back engineer VHDL code that might have been shared, written by other people online. I'll show an example. We will create block diagrams for pretty much most of the top-level design entities that we'll look at, including our projects. Here are a couple of examples that we already looked at to create a better image of what a block diagram within our context looks like. So remember the 4-bit adder that chains up 4 individual 1-bit full adders like so. In a more complete block diagram, I would show that structure, but I would also show the connections of the input and output ports of this entity to different pins of the FPGA, which sits on the board, and these pins connect to different elements, components on the board, such as slide switches that we use to input values for A and B that we want to be added, and then LEDs that we want to drive using the outputs of this 4-bit adder, where they carry output. All of these connections should be labeled with as much information as available, the names of the pins and the names of the input and output ports were connecting signals. Here is another example. This is the edge detection circuit, test circuit for the edge detection entity that we looked at before, which is just one of the components, several components here, instantiated here, connected to a clock divider that takes as an input the 50 megahertz clock signal generated on the board by the crystal oscillator and slows it down to about 1 hertz, two inverters to invert the signals that come from the push buttons on the board. So this is an example, another example of a block diagram that we create for our design entities. Yet another one, the digital clock design entity, shown here. This is the heart, the main clock counter that counts the seconds, the minutes, and the hour, the binary to BCD, and several instances of the hexadecimal to 7-segment LED display, the bouncing circuit for the slide switch, an IP, a PLL, and for the most part, pretty much most of the connections among all of these blocks that form this top level block diagram. Sometimes these block diagrams may become quite messy, and you won't want to really show really all the wires and all the connections going anywhere. For example, this 2 megahertz output clock signal from the PLL would go to pretty much all of these components, but you wouldn't really trace and show all those wires because the diagram would become too messy. Likewise with the reset signal that would have to be wired to pretty much most of these blocks, instances of the various components and the block diagram. But for the most part, you will see the connections to the outside world coming in or going outside the FPGA to the the one SoC board enough detail to convey clearly what this digital clock is all about. Here is another example. This is the top level block diagram. I don't know if you can see anything, but this here is a big uh, piece of paper put together by gluing together four different letter size pages to make enough room to draw and show this entire block diagram of quite a few components for the top level design entity inside the FPGA component of a vector network analyzer that I was trying to back engineer, and you could see, you have an appreciation of how many things are and how they are connected. This was my best shot to try to understand what was going on for the purpose of changing and modifying that. So my main point is that block diagrams are really useful. They are required in pretty much most of the reports that describe different hardware and software designs. As a main takeaway, several components that represent the main, at least, blocks of your design, connected by lines that show the relationships between those blocks. You should label them as much as possible for a more complete description picture of the top level design entity. And you should also show connections to the outside world, going outside the FPGA and coming in, connections to different things on the board or other breakout boards that you may be using in your design. So try to provide as much information on the block diagram as possible, while not complicating it and making it too messy either. So that's pretty much it. I'll see you on the next one.